Hello and welcome to this webinar on implementing EU chemicals legislation and the lessons learned from doing that. Before kicking off, I'd like to say thank you to WHO for organizing this series of webinars and in particular asking us at the European Chemicals Agency to give a contribution as to what we have learned and done in Europe. I will be starting on the story behind EU chemicals management, how REACH became to life, looking at history and how chemicals management has developed in Europe. Jenny Holmqvist will then kick off on the lessons learned in the actual implementation of the chemicals legislation here in the EU. And finally, Owen Brennan will talk about our databases and information sharing approach. There will be the opportunity during the whole webinar to have questions and answers, and my colleagues will be here to answer any questions that you might bring up during the webinar itself. I, of course, should have said, my name is Bjorn Hansen. I head the European Chemicals Agency. First, a few words on the Chemicals Agency so you can see what it is we do and how we divide up the competences between the scientific and technical implementation work and the work of the policymakers in Brussels. The Chemicals Agency was founded in 2007 here in Helsinki. It implements a number of pieces of legislation, which I'll get to in a moment. We have approximately 650 staff from a quite wide variety of countries. Our funding is partially by fees and partially by the taxpayers' money through what's called in EU speak a subsidy. Our main competences lay in data management. It lays in the assessment of chemicals. This is both the hazard and the risk side of chemical assessment. The risk management of chemicals, which in Europe is also outsourced and seen as a scientific and technical activity. And finally, we also provide support to our decision makers on the impact of decisions on management of chemicals. We call this impact analysis of chemicals. Our mission is to work with our partners for the safe use of chemicals. Basically, the together with our partners is essential because we function as a central coordinating competence body, but we work very closely together with our member states, with the Commission, with the Parliament, with industry and various NGOs and social partners. Our vision is to be the center of knowledge on sustainable management of chemicals, serving a wide range of EU policies and global initiatives for the benefit of citizens and the environment. Here, I'd like to emphasize sustainable management of chemicals, wide range of EU policies and global initiatives. Those are the key words of our existence, and I'll show you that in a moment, why that's so. Currently, we're implementing a number of pieces of legislation. I won't go into grand detail, but I'll just mention them. The main piece of legislation is REACH, the Registration, Evaluation, Authorization and Restriction of Chemicals, adopted in 2007. And since then, we've gotten a number of other pieces of legislation, all coming from various pieces of chemicals policy at the EU level. This is classification labeling, implementing the globally harmonized system. It's the biocide product regulation. It's the EU implementation of the Rotterdam Convention, which we call the PIC regulation, prior informed consent. We are also implementing the Stockholm Convention, the POPs regulation in European speak. We service our worker protection colleagues in Brussels by also doing the scientific basis for the development of occupational exposure limit values. And then we have various portals that support various other pieces of legislation. For example, we develop a portal and a database to support emergency proceedings in member states for poison cases. We call this the European System of Poison Centers. We've also developing a database to support our waste colleagues in tracking in which materials you will find substances of very high concern in order to enable recyclers better to identify which materials they want to recycle or at least know what chemicals are in the materials that they recycle. We also have an observatory on nanomaterials, and we have a database which tries to enable the tracking of chemicals legislation covering any specific chemical. This just to illustrate how we, as an agency, try to serve a multiplicity of EU policies, but always in the area of scientific and technical assessment. We look very much into the future in order to continuously, at the best way possible, support our policy colleagues in whatever policies they are developing. In doing so, we look at 3 strategic priorities. We want basically to be able to identify and risk manage substances of concern. We want to contribute to the sustainable management of chemicals through the implementation of other EU legislation than what we do here, so feed into other EU legislation. And finally, work with industry in order to ensure that the information and competence and knowledge that we collect here in ICA is transmitted down the supply chain and is put to actual use by industry to ensure safe use of chemicals. So let me get to the story behind the EU chemical management, and in particular, all the steps that took place before REACH came to life. And it's a long history, which has policy drivers, but also a number of competence development drivers, which got us to where we are now. And I'll mention, to start out with, the various policy drivers all the way from the beginnings, and then look at how the legislation was actually developed and what competences we developed in the Union to implement those policies. So first of all, there's the general environment movement in Europe, which has gone over many decades, as it has in many other countries around the globe. In the 1960s, there was the start of the environment movement. This is very much triggered, for example, by obvious physical pollution. Rivers in the Netherlands or in Italy, which had foam on top of them because detergents were let out into the rivers without wastewater treatment. So this kicked off the environment movement in Europe, which was kicked off several places in the globe, but also in Europe in the 60s. In the 70s, the understanding of what the impact of this pollution became more and more evident. And in the 1980s, it's science, the scientific community, started working much more concerted on the impacts of pollution. And science in Europe started getting substantial grants in funding for exactly doing this. And that led to an explosion within Europe in environmental legislation, but also the expansion of, or the connection, should rather say, of the European agenda with the rest of the world agenda on environment into the 1990s, which I would label from a European perspective the decade of environmental globalism, but very much built on our own experiences in failing to control pollution. The triggers in the 80s were a multiplicity of triggers. First of all, the rising affluence, which always enables people to look better around what's happening and thereby start seeing that the environment is not as pristine as they would actually like to use their leisure time, and the growing tourism. So they actually saw that there are pristine areas, or they saw places that could be pristine but were polluted. General rising levels of education, which meant that people could better understand the consequences of their own actions. Environmental organizations started popping up to a large extent, of course, also caused by the previous two factors. But to mention a few, the National Wildlife Federation from way back when is one of the grandfathers of environmental organizations. But you also have the UNEP, which got established in 1972, but of course was discussed in the end of the 60s. We have World Watch, which got established in 1974, but was also discussed to be established before, triggered very much on the concerns coming from the 1960s. Pollution itself was a problem, which you could physically see. Here in Europe, there was, for example, clear issues with acid rain, clear issues with waste disposal, and in particular wild disposal of waste, water pollution, where there was not proper water treatment, and smog issues. There it's well quoted from the 50s and the 60s, where heating and other energy sources were based very much on coal without very much filtering. Scientific evidence was building up in these times also. Everybody has heard of the Silent Spring, but there's also the prediction of the future coming from the population bomb, looking into what direction are we actually going here on this globe. This all feeds into we're initiators of today's reflections on sustainability and the limits of the globe, which are now common concepts, but back then were new and revolutionary. Politics, you also see a shift towards the starting of green parties in European countries, and also the growth of these policies and the general support in the population for actively demonstrating for these policies to be implemented and mainstreamed. In the 1970s, there's been a lot of milestones which, again, raised the awareness in the populations. Environmentalism was very much seen as being part of the answer to a number of global problems that were developing in the 70s, basically based on the argument that no matter what political system or economic situation you're in, pollution does not stop at the border, so what one actor does will affect the other. That environmentalism and going global was seen as one of the drivers of also addressing, or at least getting to discuss, a lot of much broader issues. The dates of first Earth Day in 1970, the creation in 1971 of the OECD Environment, Health and Safety Program, establishing the polluter pays principle in 1971, the Conference on Human Environment in Stockholm, which started the program itself of UNEP, and then the big oil spill off of Brittany are all events which either show as a milestone this growing universal appreciation of the need to protect the environment, or incidences like the Amoco Cadiz oil spill, which clearly came in the newspapers, and people started reflecting that pollution and damage hang together. In the 80s, where the knowledge started accumulating or being created and funded, but also further disasters, the whole discussion of climate change started in 1985. Started globally in 1985. It's been known for about 60 years before that by various scientists that this was coming. And also the International Panel on Climate Change was established in 1988 to establish the scientific underpinning of climate change. There was also, in the 80s, the issue of ozone depletion, that we were producing and using quite a lot of chemicals which depleted the ozone, which ended up creating ozone layer holes, in particular in the southern hemisphere, which created quite some health problems. One of the biggest successes in global chemicals management was the establishment of the Montreal Protocol only a few years after discovery of the hole, and within a decade, significant progress in, first of all, reducing the expansion of the hole, and then after that, even the shrinking of the hole. And the 80s also saw, thanks to some of these initiatives, the beginnings of the development of risk assessment methodology, very much at that time still at national level in Europe, and only in some areas, some countries, but still that marks the starting point of the development of consolidated science to support decision-making. In the orange arrow, you see again two of the bigger accidents which hit the news and clearly affected the citizens, the European citizens, understanding that pollution and effects are very close by each other and we need to work on it. Of course, these are accidents, but they do establish the link between chemical exposure and damage. The Bhopal accident in India in 1984, 10,000 deaths, hundreds of thousands of injured, and the Exxon Valdez accident up by Alaska with millions of gallons of crude oil leaking out and ruining a pristine environment for decades to come. All of this is sort of the political atmosphere developing, like I outlined, 60s, 70s, 80s. And I also mentioned before how the OECD program started. What is really essential for our work in Europe was the OECD program on mutual acceptance of data and good laboratory practice. This had the objective very much of reducing cost of testing in OECD countries through the development of standardized test protocols and a system of inspection of test houses applying the test protocols. But it also had the fantastic advantage that it standardized data for decision making. This is one of the pillars of all chemicals legislation which was developed in Europe after 1981. So it's the OECD test guidelines and the OECD GLP principles, good laboratory practice principles, which are inspected through an OECD network of inspectors. And this system as such creates data which can be used in a multiplicity of jurisdictions and create standardized, comparable data. And like I mentioned, the main driver was reduction of barriers to trade and costs. It had a nice effect of also limiting the use of animals, which with the decades after the beginning of the 80s became more and more of a policy issue. And the nice thing, or the huge advantage, that through having harmonized test data in one country and decisions based on harmonized test data, those decisions were much easier understood in another country because the basis was basically uniform. The global trends in the 90s started with the Rio Declaration in 1992, the Earth Summit setting out an Agenda 21. Chapter 20 had the whole chemicals agenda, including the objective of establishing the globally harmonized system. We also saw business getting together at a global level to address global environmental concerns. There are various activities on the trade side. The WTO of 1995 got established. We even have, as an ISO standard, an environmental management system developed in 96, showing that it becomes mainstream business to protect the environment. The Marine Stewardship Council was founded in 97, so moving to the marine environment. If you remember, no, many of you probably don't, but those who are old enough, the Monsanto GMO crisis, which was very much an issue of not having a successful communication on what are the risks of the products which are being put on the market. And that was also an eye-opener, first of all, for the public, that there could be things on the market which were not safe. On the other hand, also for authorities, that we need to work much harder on explaining what it actually is we're doing. And finally, the Global Sustainability Index, which was also set up in 1999, show yet another milestone in this global tendency. In the EU, if I go back, I'll get to a slide a little bit more detailed in a moment. But basically, in the EU, the first legislation started in 1967, and it developed a bit or very much with the focus of there where member states took action, and that action was similar but not the same, then there was a need for the Union to step in. Back then it was called the Community, but I'll keep referencing it as the Union. The EU needed to step in order to reduce frictions in the internal market. So it was very much not an environment drive from the EU side. It was more member states said, due to environment concerns or health concerns, they needed regulation. They developed regulation, and then the EU stepped in to try to harmonize in between them. Here are a number on this slide of activities which took place. There were different voluntary agreements. There were national rules, for example, on the local emission, on the controlling local emission from plants. There were non-binding guidance issued by the Commission. There was various community legislation led by various director generals in the Union, in the Commission. And ultimately also the EU Council was working very much in trying to establish an EU international agenda for the negotiations of, for example, Rotterdam Convention, Stockholm Convention, Minamata later on, and also the Basel Convention. Here's the slide that I'd like to spend a little bit of time on. It's rather crowded, and it only shows a little bit of the history in the chemicals management leading up ultimately to REACH and CLP, which Jenny and colleagues will explain a little bit more about. But it's a long journey which was influenced from a lot of political demands which were reacting to the population demands, but was also accumulating slowly various competences and techniques. Start with the Dangerous Substance Directive of 1967. In the beginning, in 1967, what it was all about was that there was a handful of member states who had different laws for how chemicals and chemical products, such as detergents, etc., should be labeled when they reached the consumer. These labels were different, and since they were different, it hindered the selling of one bottle of detergent in one country in the other country, since they had to produce a different label. So these countries asked the Commission to develop harmonized rules on labeling. And that's the Dangerous Substance Directive in 1967. It started as purely labeling. Then, after a while, in its implementation, the member states and the Commission who implemented it started seeing, well, if you label it, it's because you have a concern. The label says it's a carcinogen, and the concern is carcinogenicity. And therefore, we should not only harmonize the label we put on it, we should also harmonize our definition of carcinogenicity. So later on in the development of that directive, there was a harmonization of the term carcinogenicity, as an example. Later on, then again, the OECD developed an OECD test protocol for testing for carcinogenicity, which was then included in the directive as being not only do we harmonize the definition, but also what the test result needs to be in order for a substance to become a carcinogen. So in its implementation, its very roots being simply, we want products in Denmark to be, well, actually in 1967, I think it's better to say, products in Germany to be sold in the Netherlands, which was the original root of the directive. Then it became one of, let's harmonize when a substance is a carcinogen and when a substance is not a carcinogen. Eventually, in that development, came then the realization that, well, if we have this tool which not only identifies a substance as a carcinogen and obliges manufacturers, importers, and downstream users of substances to label their products, then let's also put on that label what they should do to avoid a risk. So then the concept of called safety phrases, what today is called precautionary statements, was developed within this directive. And here you can already see the beginnings of the risk assessment methodology, because that was the next step. After that was, what do we do? How do we actually start risk managing there where industry's risk management is not sufficient? then came the idea, well, let's start with all new chemicals on the market, which meant that we needed to establish a list of all existing chemicals on the market. That was done in 1981. A list of 106 substances existing on the European market was established, and everything that was not on that list needed to be notified through a union system. And in the late 80s, one thought, okay, if we're collecting this information, we might as well use it. And then the next step was, well, let's use the information we're being collected to assess the risks and decide whether or not to market that substance. And thereby introducing the full-fledged new chemicals program, which started in the beginning of the 90s in Europe, where down to 10 tons, you had to let authorities know that you were manufacturing or that you were placing that substance on the market, and you had to accompany it with an ever-increasing size of data the more tonnage you were putting it on the market. Authorities then did a risk assessment and decided yes or no for market access. So that's a big history of the 1967 directive, and I'll tell you how that triggered REACH later on. The next directive, which came into play was in 1976, was what we call the Limitations Directive. This is basically a directive which enables the banning or limiting the use of chemical substances. This was a directive which had no grand methodology in its original form. It basically said, if the member states agree, then a substance can be banned. And again, the same thing happened there. They got the directive up and running, and eventually people started asking, well, why do we need to ban? Well, we need to ban because there's a risk, and the risk cannot be controlled. Well, what does it mean to have a risk? So methodology started being developed in the 80s in order to determine when is there a risk and when can it not be controlled. And that played into the development in the 90s under the Dangerous Substance Directive of the risk assessment methodology. Chemical Risk Directive from 1980 is the first worker protection legislation set up, which basically obliges employers to avoid or minimize the risk to workers in the workplace. It didn't have a big machinery inside itself, as did any of the predecessors, on how to do that risk assessment. First started by setting up the general principles, and then learning by doing, started developing the tools for doing so. 1991, Plant Protection Products, which established a very comprehensive EU program of identifying active substances on the European market for plant protection purposes, and then setting up a mutual recognition system, or at least a mutual information system for national product authorizations. And here, this was the first real EU risk assessment program that was set up and started working. As the little cousin of that was the Existing Substances Regulation, came 2 years later. It established in regulation what a risk assessment was, based on what was established in 1992 for new substances. So in a sense, the plant protection products kicked off a process that was accelerated in the Dangerous Substance Directive for new substances in 1992 and accelerated once again in the Existing Substances Regulation in 1993. And I'll get to the lessons learned from that a little bit later, because it's very much the assessment of the Existing Substances Regulation, the full-fledged development of the Dangerous Substance Directive and the Limitations Directive, which gave the foundation for why and how REACH is today. Other pieces of legislation that came after these basic building blocks, the Seveso Directive, which was basically a reaction to the Seveso accident, where, again, quite a significant amount of citizens living around a plant around the city of Seveso died or seriously injured, and this directive was set up in order to avoid this type of chemical accident, or at least minimize chemical accident. from happening again by having emergency plans, by having information to the local public when something could go wrong, and also establishing minimum risk management systems on site, depending on what the hazards of chemicals are. 1998 Chemical Agents Directive is the further development of the Chemical Risk Directive from 1980, and is the comprehensive package of controlling risks to workers from chemicals, but also from various other hazards, biological agents and physical hazards. Finally, Biocides Directive was adopted in 1998 as a little sister, since existing substances regulation is a little brother, so a little sister of the Plant Protection Products Regulation, due to history, which I won't go into here because we're focusing more on REACH. Actually, the Biocides Directive was written simultaneously with the Plant Protection Products Regulation, but there was not enough political will back then to get it adopted in parallel with the Plant Protection Products, so it ended up being adopted 7 years later when the political will was there. So that's a little bit of a history which shows that it's started, environment, chemicals legislation in the EU very much started based on internal market considerations, very, very practical. And then very quickly, after starting just with a little toe inside the door, one starts seeing there's a need to develop methodologies. Those methodologies have to be harmonized. The conclusions of those methodologies needs to be consistent. And eventually, you have a system of methodological development so that when we got to the year 2000, we in Europe already had between 10 and 25 years, depending on what it was, experience in hazard assessment, risk management, and socioeconomic analysis to guide decision makers into what is the most appropriate risk management tool to implement. In 2007, and this here is maybe, I should say, during the year 2000 to 2006. This was the period in which REACH was developed. But it was highly influenced by the history that I've just given you, but also what happened in the years from 2000 to 2006. Many things were happening in the chemicals area which kept influencing how the REACH regulation ended up looking. And here you'll see the output of the existing substances regulation. Basically, in its 14-year history, starting 1993, ending in 2007. So this is a regulation which basically says, let's collect all available data, do priority setting, do a risk assessment. After you've done the risk assessment, check what risk management is needed and implement it in a very big EU-wide machinery with hundreds of experts involved. In those 14 years, we managed to do 141 or identify 141 substances as priority chemicals. We managed to risk assess 137 of them. There's a technical reason why the 4 are missing. This is not because we were lazy, simply technically, scientifically not possible. What is interesting, though, is that we didn't manage to, in those 14 years, to come to conclusions, risk management conclusions on all 137 of them. You only see here that there are 72 of them for which there is a risk management conclusion. We didn't reach risk management conclusions. That's a milestone in itself. But after 14 years, having risk managed 59 out of 72 substances was not a very good track record. And that was definitely one of the big reasons why we ended up reversing the burden of proof and getting to REACH, was that this system was overburdensome, put all the efforts on authorities to find information that showed that there was a problem, and it gave industry an incentive not to give information that there was a problem. But I'll get into that in a moment. So what are the big successes we had achieved in the previous legislation before REACH started? So here we're looking at the 1990s and the first couple of years of this millennia. Well, already in 1993, when the existing substances regulation was adopted, it was put into law that it had to be implemented electronically. And this for 1993 was somewhat of a revolution. So the whole of the EU industry was obliged to use electronic means to submit information to the European Commission, and the Commission used only electronic systems to work with the data. So basically, through these 14 years of operation, we demonstrated that it was possible to have large data gathering exercises and to summarize the whole information on the high production volume chemicals. We had an agreement on risk assessment principles. Not only an agreement on risk assessment principles, we also had put that agreement to active use amongst the member states. And here the union grew in the meantime. Initially it was 12 member states, then it became 15 member states who all agreed on the principles and agreed on how to put those principles to real work on individual chemicals. There was a general agreement on priority setting, and we achieved this EU harmonization of the risks of very many controversial chemicals, which formed a very solid basis to union-wide risk reduction. So, for example, short-chain chlorinated paraffins, trichloroethylene, the brominated, the penta, octa, and deca polybrominated diphenyl ethers, brominated flame retardants, just to mention a few, which today are now covered by, for example, the Stockholm Convention. But those were successes in terms of implementation of agreed methodology, getting to agreed conclusions, and thereby paving the way for agreed EU-wide risk reduction. So basically, successes were that we had technical tools to get agreement efficiently. What were the problems? These are a list of all the problems, and let me tell you up front, REACH didn't solve all of them yet. We're still struggling. But one of them, data gaps. 86% of high-volume chemicals had less than OECD base set data. This was the result in the EU. It's also the result in the US. EPA conducted a study in the late 90s, concluding exactly the same. And as a corollary, the US Academy of Sciences in 1986 concluded the same. So basically, if you look at 2006 as being the date of adoption of REACH, in the 2 decades preceding that, there had been no additional information generated, neither in the EU nor in the US, of any substantial matter. And 86% of all chemicals didn't even have the minimum data set to allow a risk assessment to be done. And these are not only chemicals, these are high volume chemicals. So big political driver of REACH was, without data, you can't set priorities, and you can't do a risk assessment, so you can't do risk management. Then came the risk assessment process. Took far too much time and was far too resource intensive. This fact that we only were able to do 137 chemical risk assessments in 14 years was seen by policy as being way too resource intensive. And one of the reasons for that was that the burden of proof was on public authorities. What I explained before, that you sit there as a public authority, you only have data on 14% of all the high-volume chemicals on the market. You then have to find which ones are problematic. Well, you can't define problematic if you don't have the data. You then select something which you think could be problematic, but definitely not based on the data you have in front of you, but based on your experts who think there might be a problem. And then you go and you do the risk assessment. You do the risk assessment, you ask industry, can you please give me the information that proves that your substance is not handled safely? That, of course, in itself is a recipe for conflict. So basically, the result was that we had to find a way of putting the burden of proof off the public authorities, but I'll get to that in a moment. We had generally a problem in the past legislation of getting information from downstream users. How are the chemicals actually being used? Where do they actually end up? Do they end up in consumer goods or not? The system was in general inefficient. This is more of an EU internal cuisine, but is relevant because it did put a push behind REACH. That was that we had a lot of regulations in many pieces of legislation, regulations and directives covering chemicals, a lot more than today, believe it or not. And back then it was said, well, can we either get order in this or maybe even merge a lot of it into one piece of legislation? So that's why REACH is so thick, is because it actually streamlined and made consistent 40 pieces of legislation. And then one of the big arguments also was that with our new chemical system, which looked at down to 10 kilos, and our existing chemicals system, which only looked at above 1,000 tons and didn't even require data above 1,000 tons unless it was available, there was a clear imbalance between new and existing chemicals, which meant that we blocked innovation. It was much too expensive to put a new chemical on the market compared to an existing. So a chemical company or a user would prefer to use an existing chemicals, even though it was more hazardous, more polluting, provided less technical specifications than a new chemical, simply because it was cheaper. And that imbalance prevented innovation and prevented safety. So those were all the main drivers of what were the problems in the previous legislation. What REACH does, it takes care of the data gaps. It speeds up the risk assessment process, though we still have a lot to learn and a lot to do there. It changes the burden of proof, and we're getting better and better at that, and I'll put a few words to that. We didn't solve the information from downstream users. That was too complicated to get solved, but we did improve the obligations to communicate in the supply chain. We increased the efficiency by merging 40 pieces of legislation into one and creating consistency and clear boundaries, or actually removing the boundaries and making one continuous system out of it. And finally, we merged new and existing chemicals. So we took existing chemicals, we increased, I should do like that, where there was hardly any obligations, we increased them quite significantly, and we lowered the new chemicals burden quite significantly to have a compromise package. But in any case, whether a substance is new or existing, it's treated exactly the same in Europe, and this means we have no hindrance to innovation, at least from the perspective of the legislation. So the principles in REACH is industry, responsibility for safe manufacture and use. Now that was a real complicated policy principle to implement. Get to that in a moment. That deserves quite some attention. Deal with the burden of the past with a systematic program for registration of old chemicals. So basically, this fact that we only knew 14% of data, we now want 100%. So that companies have the data so they can self-regulate, and the citizen can say, okay, industry has the data, they've self-regulated, so we have increased confidence in chemicals. So that's why we have a system of information requirements per tonnage that all chemicals must meet. But it's also part of the reversal of burden of proof, enabling industry to take responsibility. I'll get to it again, like I said. Basically, get adequate information on hazards while minimizing the use of experimental animals and the costs. So there's quite some flexibility built into REACH to enable meeting the information requirements from alternative data, as long as it answers the critical questions of, is it a carcinogen, is it not, and at what level is it a carcinogen? Then there's a number of targeted activities, which is basically spreading more clearly the roles of the European Chemicals Agency, of the European Commission, and of member states to get the maximum effect of each player in the system. So it's articulated better who does what after an analysis of looking at who is actually better at doing what. And it's on that basis that ECHA was created, and why ECHA is created and has become or is so much bigger than the predecessor in the Commission, because it was seen that having more centralized work increases inefficiencies and increases consistency. And then finally, there is an increased effort for enforcement at national level. Let me get back to this reversal of burden of proof, because that is a really difficult concept to implement. Very easy to say, very difficult to implement. There's the clear link to the polluter pays principle. Polluter pays means that industry should take the responsibility. But how do you develop an auditable system for industry actually to take responsibility? The only way to do that was at least our conclusion. And I mean, we tried a lot of models, discussed a lot of models, had internet consultations on a lot of models of doing it. But the only one that we ended up thinking was efficient and auditable is you must establish a minimum information requirement that every chemical that is competing on the market at that level needs to meet. And then you have to put the obligation on industry to apply specific methodologies to manage their risks or to assess their risks and then tell them how to manage them should the risks not be managed. So it's a very detailed system which is very prescribed. Otherwise, you will never get the reversal of burden of proof. That was our conclusion, and Jenny and Owen will be explaining a little bit how that system works. So ultimately, as a conclusion to my part of this talk, in explaining the years before REACH came into place, we managed with the REACH to consolidate about 60 pieces of legislation. There are still 40 pieces of legislation to go, which we're working on, looking at interfacing better with REACH, with classification, labeling, etc. But we have considerably simplified the legislative landscape. We've definitely not simplified the obligations within that legislative landscape, but it has become more consistent and more synergistic, which means that the fulfillment of the higher obligations that the legislation puts on industry and authorities has become overall more efficient and more consistent. We think we have a very solid framework of legislation, implementation tools, and thereby decisions coming out in the end, which is built up on 50 years of experience. And clearly, even with 50 years on the back, we have a lot to learn. So we're looking at continuous improvements, which definitely are needed. And these are needed also to overcome many of the global challenges that we all are facing together. So with that, I'll stop and I'll say thank you very, very much for your attention and hand over to the next speaker. Thank you.